This is problem 19 of the MIT integration big qualifying exam 2012, which is the indefinite integral of 1 over the square root of e to the power x minus 1. So let's go ahead and try and see how we can solve this. So the first thing here, what we're going to do is we're going to say let u be equal to the square root of e to the power x minus square root of e to the power x minus 1, such that u squared is equal to e to the power x minus 1, and therefore u squared plus 1 is equal to e to the power x, right? And we can now say that e to the power x dx du equals to 2u, such that e to the power x dx is equals to 2u du, and dx will be equal to 2u over e to the power x du. We know from here what e to the power x is in terms of u. So since e to the power x equals to u squared plus 1, then what we have is dx is equals to 2u over u squared plus 1 du. So this is an important thing to consider, so that when we have our integration of e to the power 1 over square root of e to the power x minus 1, that's the same as since this part is u, it's 1 over u, and dx, since our dx is here, which is 2u over u squared plus 1 du. So this u and u would cancel, so we have twice the integration of u squared plus 1, right? And since our integration is 1 over u squared plus 1, for those of you who are familiar, we know that when we're integrating 1 over x squared plus 1 dx, we know this to be arctangent of x plus the integration constant. So using this formalism, we know now that our integration is arctangent of u plus c. Since we had what we had previously done was equating u to the square root of e to the power x minus 1. So essentially, when we integrate e to the power x minus 1, that gives us 2 arctangent of the square root of e to the power x minus 1 plus c. And this, ladies and gentlemen, is the answer that we have. So this is one way of doing it. We do have another way, and we're going to try and see how to integrate in that second method. So we have e to the power x minus 1 as our integral, and that is the same as if we do it such that we have our square root ex divided by ex minus 1 divided by ex, right? Such that this becomes and suddenly we would have an ex over 2 here, so that when it goes in, it cancels with that. So we have on top e to the power negative x over 2 over the square root of 1 minus e to the power x dx. So since this is the square of this, we could just say let e to the power negative x over 2 be equal to something like sine theta, right? And such that e negative 1 over 2 e to the power negative x over 2 dx d theta will be equal to cos theta. And so e x over 2 dx can be substituted with that, right? Is that our integral e to the power negative x over 2 square root of e to the power negative x is equals to, since this part here is the same as this part here, we'll put negative 2 cosine theta d theta over the square root of 1 minus, since e to the power negative x over 2 is equal to sine theta, this would become now sine square theta. So this becomes negative 2 cos theta d theta over a square root of cos squared theta, because 1 minus sine squared theta is that. And this becomes now, right? Because this and that would cancel. And this becomes now 2 theta plus c. But since we said e to the power x over 2 equals to what? Sine theta. What that means is that theta is equals to arcsine of e to the power x over 2. And since the integral we had resulted in 2 theta plus c, the same as 2, the integral of 1 over square root of ex minus 1 is equals to negative arcsine of e to the power x over 2 plus the integration constant. And that is, ladies and gentlemen, our answer.